Hello students, in this video we are going to look at some non-basic figures and we will try to find the volume. In the first example we have a triangular prism, however there is a cylindrical hole taken out of it. So the volume should actually be the volume of the triangular prism subtracted by the volume of the cylinder. However, we can also just follow the formula of prism volume, meaning we will need to find the area of the cross section and then multiply it by the length of the prism. So very easily, if I draw the cross section of this prism, I should get a figure like this. So a triangle with a circular hole in the middle. And we have to be careful with the unit here. Everything else is in meters, so 180 centimeter we have to convert into 1.8 meter, divide that by 100. And here diameter is 0.4, so obviously radius is just half of it, so the radius should be then 0.2 meter. Now to find the area of this cross section, we will have to find the area of the triangle. Base 3.2 times height 1.8 divided by 2 and then subtracted by the circle pi r squared, so pi times 0.2 squared. And putting that in the calculator in one go, we have 2.754336 and so on and so on. So the volume of this prism is then just the area of the cross section multiplied by the length of the prism, which in this case is 2.5 meter. And as the end result, the volume is then three significant figures, 6.89. You see here after 8 there is 5, so then we round it up, 6.89 meter cube. The next example is a hemisphere with radius 3 decimeter. However, our answer later on has to be in milliliter. So this is about capacity of this container. So capacity is how much liquid or gas or whatever that you can fill into this three-dimensional figure. So in this case, it's as if it's a bowl or something with radius 3 decimeter, and 3 decimeter is the same as 30 centimeters. So remember the step. Decimeter and then centimeter and millimeter. So 1 decimeter is going down times 10, so 30 centimeter. Why do we need to convert that to centimeter? Well, remember with capacity, if we have a cube of 1 centimeter by 1 centimeter by 1 centimeter, then if you fill in some liquid into this cube, then you will have a capacity of 1 centimeter cube, 1 times 1 times 1, so 1 centimeter cube. And in real life, this is what we usually call 1 milliliter. On the other hand, if you have a cube of 10 centimeter by 10 centimeter by 10 centimeter, so meaning it's actually 1 decimeter each. So 1 decimeter, 1 decimeter, 1 decimeter, or 10 centimeter, 10 centimeter, 10 centimeter. Then the volume is 10 times 10 times 10, which is 1,000 centimeter cube. This is what we usually call 1 liter in real life. So centimeter cube is milliliter and decimeter cube is liter. So 1 liter is 1,000 centimeter cube, or this is called milliliter, and 1 liter is actually 1 decimeter cube. And if we have here 1 meter by 1 meter by 1 meter cube, then the capacity of this container is then 1 kiloliter or 1,000 liter. So going back to our question here, since we are asked to find the answer in milliliter, and milliliter is the same as centimeter cube, then therefore we can bring this unit into centimeter, and later on we do not need to worry about converting the unit. Alright, so the volume of a sphere, a complete sphere, we talked about it already before, is 4 pi r cubed divided by 3. And later on, because it is just a hemisphere, it is just half of a sphere, then of course we have to divide the result by 2. So don't forget in the end. Let's do that right away. 4 pi times radius, which is 30 centimeter cube, and then divide it by 3, and don't forget in the end you will need to divide that by 2. If we enter that in our calculator, so we have here the whole sphere, which is 1013 and so on and so on, and then we divide that by 2 because it's only hemisphere. So we have to 3 significant figure 56.5. So we will have 56.5. The unit was centimeter cube, and because centimeter cube is the same as 1 milliliter, then we can also just write down that this is 56.5 milliliter. Okay, good luck with the exercises with a bit more of non-basic figures. It works exactly the same. You just have to think about it a little bit further. Sometimes you have to subtract, add, or put things together, or divide by 2 if it is only a half, and so on. Good luck!